Good morning, and thanks for joining our latest webinar, where we will talk about Gartner recently recognizing us as a cool vendor. We will promptly start at 10:03. Let's give some of the other folks who are probably finishing their latest episodes of Game of Thrones to finish that and dial in. Back at you in 3 minutes. All right, good morning. Again, this is Manish Gupta. I'm the founder and CEO of ShiftLeft. Super pumped to be here today to tell you about the recent award from Gartner, where Gartner has recognized ShiftLeft as a cool vendor in DevOps. Gartner's category of cool vendors is because a vendor is innovative. As it says sort of here, enables users to do things that they couldn't do before, that the vendor solution is impactful, has a business impact, not just technology, and intriguing, right? It is a novel approach that has caught Gartner's interest. And what makes this award the most exciting for me personally is that this actually comes from Neil McDonald, who is my favorite analyst, and I consider him to be one of the best security analysts in the business today. And so as you can imagine, we wanted to get in front of you to show you why we believe we are cool. And with that, look, I think our perspective is that software is eating the world. There are many aspects of software that have significantly changed and continue to evolve at a very rapid pace. Yet, when it comes to security, we seem to be stuck in the dark ages. Let's take let's summarize sort of what is happening in the world of software. I'm sure you're seeing this firsthand. Your developers, your engineers are releasing code ever faster. The monolithic applications of yesterday have become decomposed into multiple microservices, which further enables faster evolution. Almost all of our apps use some open source software. which is not necessarily all in our control. And how our developers use a particular library and whether that usage creates a vulnerability is a very hard problem that there are no solutions available in the marketplace. Yet, when it comes to security, we have been and we continue to today deploy security tools that are largely writing attack-based signatures, whether it is a next generation firewall, whether it is a web application firewall, whether it's an antivirus. Look, all of these technologies are at the end of the day writing signatures, algorithms, and if you are really fancy, artificial intelligence to detect attacks. Fundamentally, this environment is one where we are constantly playing whack-a-mole with attacks, and it's expensive and it's reactive. And finally, as we are developing software, deploying software in hybrid cloud, we are, in essence, becoming a SaaS, software as a service. And in software as a service, a recent article from Economist comes to my mind where they call data as the new currency. And despite spending all of this money, we don't get visibility, granular visibility into what is most important to us, which is our data. And our data is usually customers' data that customer is trusting us with. And so it's safekeep is needs to be one of our top priorities. And as we look at some of the worst breaches that have taken place in the last couple of years, it becomes rather clear that the bad guys understand this. They understand that we continue to use legacy security technologies, and therefore they are easily able to penetrate, exploit our applications. Sometimes they use known open source vulnerabilities to get into our applications. Sometimes they use application vulnerabilities to get into our application. And sometimes some of these applications are actually just handing this valuable customer data to the attackers as an open S3 bucket. Because as I argued in the previous slide, we just do not have good visibility into what is happening with the data. And so I guess, is it any surprise that we continue to get breached and continue to lose all of this data? And as Gartner says on the right side of this slide, a vast majority of the attacks will be on the custom code in an application. And I think all of these attacks bear good examples to that statement. A couple that I would highlight on this particular slide that are worth digging deeper into is, for example, the top left, the Muni system hacker hit others by scanning for year-old Java vulnerability. If you Google, you will find the details of this vulnerability, or rather this attack. And the way this attack manifested is that the attackers serialized data into an application that then serialized data into an Apache library, which was not expecting data to be serialized, right? So, and as you read the details of this particular exploit, once this came out in the news, the application authors were pointing fingers at the library owners to say, well, you created a library that is vulnerable. And the library owners were saying, well, look, this was our assumption. This is part of our documentation that you will not serialize data into our library. And so contextual usage of software, contextual usage more specifically of an open source library by an application is an evolving attack surface that, again, we will dig into in the next couple of slides as to how we don't get any visibility into it. So in that backdrop, let's dig deeper as to how traditional security works, right? What all are we doing? Because we clearly not sitting idle. In fact, it's just the opposite. We have, in the world of security, we have way too many things to do. So let's start by looking at what do we do in the development and test environment, right? This is clearly an alphabet soup, and as you can see, and perhaps you have firsthand experience, you are using a range of security technologies, starting from static code analysis, static application security testing, as Gartner calls that category, Perhaps you're also using dynamic application security testing. And maybe over the last couple of years, you've also invested in an interactive application security testing. Most, if not all, of these products are rather old and date to a time when the OSS usage was minimal. And so none of these tools really give you visibility into what open source libraries are you using and whether they have vulnerabilities, or more importantly, in the manner in which you're using these open source libraries, are new vulnerabilities manifesting. So you probably invested in a source code composition analysis tool. All of these tools, you know firsthand, create a bunch of false positives. So after you've invested in these tools, after they take hours to run every time you do a new release, you then spend a considerable time tuning for false positives, because you don't want to look bad by telling your engineers, hey, here are the 182 vulnerabilities that you need to go fix, right? You'll clearly get laughed out of the door. So you spend a bunch of time tuning for false positives so that you can give a far more specific, a high degree of confidence list to your development team so that they can fix them. Once fixed, the new patch is deployed. As you can see, as you just verbalize this workflow, it becomes apparent that this workflow was designed for an era when we had one big application and we were probably doing one release in 6 months. Because the amount of effort that it takes to do all of this, clearly, to bring that forward to today's environment where that one application has gotten decomposed into 20 microservices, and perhaps you're doing one release a week, it's clearly untenable. This results in high cost of buying and maintaining these tools. You have to constantly tune these tools to cater to your application, because your application is different than mine, and my application is different from Eitan's. There's significantly high operational costs because these tools, as we pointed out earlier, create a bunch of noise. I mean, that's just a fundamental problem with code analysis, is that one can never understand deterministically how a piece of software will work, will behave in runtime just by looking at source code. And one of the key things that we see in our customer environments is, over time, this approach sows a significant amount of distrust between security and engineering. Because the goal of security is to point fingers at engineers to say, hey, here's a list of vulnerabilities that you need to go fix. And engineers are tired of receiving false positives, and so they don't really trust the output of many of these tools. And this is just one half the story. The other half of the story is really what matters, which is you deploying this application now in production. And what do we do in production? Well, if you are a sophisticated organization, you've deployed perhaps a web application firewall. But if you've already started to embrace the hybrid cloud, you've probably already come to the conclusion that WAFs don't work in a microservices architecture. They're just too expensive to tune as rapidly as your software is evolving. So maybe you're just making do with a next generation firewall, or maybe nothing. And all of these technologies, threat-based technologies, WAFs, next generation firewalls, perhaps intrusion detection systems, create a bunch of alerts. Same problem as on the left side, but now this is production network. So what do? You submit all of these alerts into a SIM. Now your SIM has 100,000 plus alerts a day. Now what do? Well, now you've got to build a SOC, a security operations center. And maybe you need to manage 24/7 so that a pair of eyes is looking at every single alert, no matter what time it is, and trying to then follow a script as to what to do with that alert. Again, as I'm just describing, I think we can all feel it in our bones that this threat-focused approach is the security team like a hamster on a wheel. There is no line of sight. I don't see the light at the end of the tunnel. We just gotta continue to do this, because guess what? By focusing on threats, the initiative is with the bad guy. He gets to shoot first, and then we get to react. There is significantly high operational costs. And fundamentally, protecting the application in this manner doesn't address the underlying root cause. Because what is the underlying root cause? The underlying root cause is that your application has a bug, has a vulnerability, has a weakness that the bad guy is exploiting. And by constantly reacting to threats, you're actually never addressing that underlying root cause. And these two sides, what we are doing with our software in the development and test and how we're deploying it in production, even though they're two sides of the same coin, in the current traditional security architecture, there's a wall between them. These two sides almost never talk to each other. And fundamentally, what we get out of this traditional security model is a model which has high cost of buying these 10 plus tools, high cost of operationalizing these tools in our world. And yet, we are left with high risk, as is evident in the number of breaches that we see almost on a daily basis. It is this problem that left ShiftLeft to ask the question, can't we do better? And at ShiftLeft, we flip the problem on its head. We ask ourselves the question of what is it that we are trying to protect? Not we are trying to protect from, because that would be attacks, but what are we trying to protect? Well, what we are trying to protect is this piece of software. You could call it a microservice, you could call it a workload, you could call it an application. But what does it consist of? It consists of software that your engineers are writing, your software, your custom code. But as we talked about, it increasingly consists also of open source libraries. And it might have some third-party libraries. All of this may, in your environment, be changing once a month. But we have some customers in whose environments this is changing 20 times a day. But every time this changes, this software needs to be protected from, number one, data breach. As we talked about earlier, data is the new currency. Bad guys know that if we are an e-commerce application, if we are a technology company, whatever we might be, we are aggregating a bunch of customer data, a bunch of employee data perhaps. And that is what is most valuable. And that's what these bad guys are after. So how can we protect the software from leaking data that is super important to us? How do we protect the software from known vulnerabilities? Vulnerabilities that we know exist in the software, but for whatever business reason, we've not yet had the time to fix them. Can we get protection for those vulnerabilities? And finally, the hardest problem of all, are there unknown vulnerabilities, vulnerabilities that we don't even know exist in the software? Can we protect that software from unknown vulnerabilities being exploited so that we can get some time to prioritize and fix these vulnerabilities? Because remember, the underlying root cause is still these bugs and these vulnerabilities. Till they are fixed, we really don't land up decreasing our attack surface unless we have compensating controls that we will talk about in a second. But if we step back and took a bigger view of this world, every application, every microservice is different. And so every application or every microservice needs custom protection for its own attack surface. And that is what we do at ShiftLeft. Let's talk about how we do this. In the traditional security model, we talked about how dev and test and production are separate. There's a wall between them. We also talked about how at the end of the day, there are two sides of the same coin. It's the same software that on the left side is source code, and that on the right side is now an application that our customers, our employees are accessing. So the first thing that we need to do is bring them together. The way we do this at ShiftLeft is every time a microservice in your environment changes, every time your developers write a new version of a microservice, every time they add in a new open source library to your application, the attack surface changes. Consequently, within a matter of minutes, Every time a microservice changes, we extract its security DNA. Think about security DNA as everything that is security relevant in your piece of software. This includes what are the vulnerabilities, known and unknown. So we do not rely on any CVE patterns to do pattern matching. We actually do code analysis, but modern code analysis on your application, which is why we are able to do this in a matter of minutes. Here, the technology that we use is an invention of our chief scientist, Dr. Fabian Yamaguchi, who did his PhD in the area of code analysis, and in 2015, published an IEEE white paper in which he showed how this approach he used to find 18 zero-day vulnerabilities in the mainline Linux kernel. We're talking about 2015. Analyzing arguably the most analyzed piece of code on the planet, and yet finding 18 zero-day vulnerabilities. This white paper is on our website, and you're welcome to download it and read it for yourself. I will warn you, the amount of math there is in that paper, I only understand 10% of it. So kudos to you if you can understand more than 10. So like I said, we use this modern code analysis to extract security DNA. Security DNA consists of known vulnerabilities as well as unknown vulnerabilities. For us, there's really no distinction because we are finding these vulnerabilities afresh in your software. We extract all the open source libraries that your microservice might be using. And along with your custom software and these open source libraries, we create a semantic graph. It is this graph that we then search through to find out where the vulnerabilities might lie. Think about this graph very much like a Facebook social graph. All the relationships across all the various data elements and data flows becomes rather apparent. And lastly, what we identify in this piece of software is what is the sensitive data. And this is super important. Based on our customer feedback, this is the feature, this is the capability that customers love the most from ShiftLeft because there is nothing like that in the market. So it bears a double click. Imagine the application of Amazon, the retailer, the e-tailer rather. We all access it. We've all created accounts. In essence, it is the application, the Amazon application, that in its source code has some variables, some data objects, such as maybe a customer first name, where they're going to put my first name or your first name when you submit it. Similarly, there's going to be another data object which might say customer last name, and then yet another maybe customer's credit card number. Now today, the way data visibility works, if at all it works, is by looking at all of these data elements on the wire, where it might be encrypted, where the volume of data is enormous. In case of Amazon, as you can imagine, it's in the millions of credit cards flowing constantly back and forth. We flip the problem at ShiftLeft by, instead of focusing on the variables, on the data which is on the wire, we follow the variables in your source code. And because of the semantic graph, we are very good and very accurate in understanding the important variables, the important data objects in your source code, and how they're flowing. And when we do the demo, this will become a little bit more real. It is such a novel concept that unless you actually see it, it becomes hard to understand. So to summarize, security DNA consists of three important things. One, vulnerabilities known and unknown. Second, open source software. And because it is one singular graph of your software and the open source libraries, we are therefore able to find situations such as, well, this particular open source library does not expect data to be serialized, but you're not validating input data, and therefore you risk taking serialized data and feeding it into this open source library. Solution to this particular problem, we don't believe anyone else in the industry can provide. And finally, visibility and very granular visibility into the sensitive data being used by your application. We extract this in a matter of minutes every time your software changes, and we then take the security DNA to create a policy that informs our microagent how to protect this application in production. As you can see, this is what allows us to not react to threats. An application can only be exploited by exploiting one of its weaknesses, one of its vulnerabilities. And if you can extract all the vulnerability information and create a custom agent for every version of every microservice, this is the approach that allows us to provide extremely accurate and high-performance security solutions for protecting applications in production. That's the top half of this equation. That is the advantage of bringing dev test and production together, is for the first time, we can leverage intimate understanding of the application to provide protection for it. But things get better. We can also use runtime information to prioritize code analysis. I think you'll agree with me that it is impossible to replicate production environment in your QA lab. And so to take production data and feed it back into code analysis for the first time allows developers insight into, you told me about 3 vulnerabilities. I thought maybe this is part of a backend code that will never get exercised, but boy, am I seeing 23 calls per minute going to it. This is what makes the security very efficient, both from a CapEx perspective, but also from an operations perspective. And finally, it allows collaboration between security and engineering because both sides are looking at the same thing, which is how does an application behave in production. There are no assumptions being made here. As I said, this is the model that we get so excited about. This is the model that we believe not only lowers cost for you, but significantly reduces the risk, because as opposed to constantly reacting to threats, we are helping you fix the underlying root cause in your software. So to summarize, why ShiftLeft? And well, here are a few reasons. Number one, agility. Look, software development cycles are only going to get faster. We went from virtual machines to containers, and now we're talking about PaaS, platform as a service, function as a service. And the most granular currency will continue to be software that you write. And so instead of focusing on other layers that the software might run on, by focusing on the application, ShiftLeft can provide you a very agile security solution that runs as fast as you want to run in DevOps. Cloud agnostic. Our microagent is surgically instrumented into your application. So today we support Java. Soon we will support C# and .NET. But for Java, essentially, we are instrumented alongside your application into the Java virtual machine. Very much like some of the state-of-the-art application performance management tools such as New Relic and App Dynamics. And that instrumentation allows us to be cloud agnostic. You can run ShiftLeft protection wherever you can run your Java virtual machine. Be it AWS, be it Azure, be it Google Private Cloud, be it Google, or be it your private cloud. And as I mentioned earlier, we are focused surgically on the application. As we saw on an earlier slide, that is what the bad guys are after. This is also vehemently supported by AWS and Azure and Google in what they call the shared responsibility matrix. It makes it clear for their customers that they should be focused on protecting their application, because everything below it is increasingly going to be the domain of the cloud provider. Granular data visibility. As data is the new currency, we truly need to understand how data is flowing across our microservices. An example that comes to my mind most recently, which was in the news, is Mark Zuckerberg going in front of the Congress and really saying, well, I don't really know where all is our data going? And if Facebook, with its hundreds and thousands of engineers, doesn't have good insight into how data flows throughout their infrastructure, us mortals with the far fewer engineers will clearly have a very complex task at our hand unless we get technology solutions purposefully built for today's world. We are not threat focused. We do not write a single threat-based signature at ShiftLeft, even though it's something that I've done for the last 15 years in my various companies where we were threat focused. For the first time at ShiftLeft, I do not have a person writing signatures for threats. Why? Because as we've talked about, we understand the attack surface and surgically protect your application against that very attack surface. So it doesn't matter to us what attacks bad guys throw at us. We are trying to protect the underlying vulnerability. And my favorite feature of our product is when we see something bad happening in production, we give you the line of code where the vulnerability lies so that the developers can fix it. I just wanted to pause for you to appreciate how important that capability is. Every time there is something bad identified in production, we give you the line of code that the developer needs to go fix. This significantly reduces the operational cost of running security. This significantly reduces the attack surface of the application. With that, let me pass the ball to Eitan, who's our VP of User Design, to actually give you a demo so that much of this becomes real.
Are you muted? Screen. Good morning. Good morning. There we go. Just a brief echo there. Yes, so as Manish pointed out, yeah, I'd like to give you a brief look at our product experience. Hopefully you'll recognize many of the capabilities that he already gave you a pretty comprehensive description of. So I'll just get right into it. So right now, as you can see, I'm logged into ShiftLeft, and what you get right away is a dashboard that gives a high-level overview of all of the applications that are being analyzed and monitored by the ShiftLeft solution. So in this case, I have one application, which is a test app that has various security problems with it, and I'll kind of dig into what you can see and some of the more concrete use cases of how I might discover and then resolve a security problem with this application. So before I click into it, I think one thing I want you to consider as I go through this is, as Manish had pointed out, the ShiftLeft approach has these two insertion methods. One is the build time analyzer that will sort of continuously analyze the application at build time, with each version that's built in your CI/CD, and then there's the runtime component where the application is running in an ongoing way, in production. And that analysis, those two data sets are effectively going to be blended as you explore the security of your app through this ShiftLeft user interface. So I'll go right into the app right now. And what we're looking at here is what we call the app summary view of the app. And I'll walk you through some of the interface elements here. So the first thing I should point out is the default time window of this experience is the past hour. So as you can see, this is kind of a real-time dashboard of the application. So it's very operational in nature. And the very first widget you'll see up here is the application throughput chart, which shows you, really the context of the application running in production. This application, I'm just hitting various API endpoints on it. So it's a web-facing service. And as you can see, when I initially triggered some traffic on the app, these red lines indicate that there are violations detected here. Violations are effectively security problems with this application. So the other widget I'll point out right away is this center one called Violations Grouped by OWASP. And what this is showing you is, in a very condensed display, all of the security insights that are relevant to this application. So what I can show you here is, in terms of injection vulnerabilities, so this could be an SQL injection or even a file injection vulnerability, in the code, in other words, at build time, we saw 43 discrete places in the code where an injection is possible. But we have not yet seen any of the injections attempted at runtime. What is the reason for this? Because I'm the only one hitting this application right now, so I haven't actually tried to hack it just now. However, what I can show you here is that there are 84 discrete places in code where a sensitive data leak is possible. However, with the regular traffic I've generated, there are 11 of those locations where we're seeing actual runtime activity that is causing the leaks to happen. So, presumably, if I were the owner of this application, I would very likely go and resolve the security problems where I'm seeing it happening at runtime in addition to that detection at code. And so seeing this blended data set, in my opinion, is an amazing way to prioritize how I tackle these security problems. So walking you through the rest, or the wings of this UI as I call it, on the left-hand side we have triggers. For a web application, this is going to mostly look like web routes, but a trigger is any method of the application or any class method that will initiate data flows in the application. So in this case, there are various endpoints on the app, and I've hit these few, and those have caused some of the security issues to get flagged as runtime problems. And so we're seeing traffic, by the way, in calls per minute for each of these triggers. On the right-hand side, we're looking at data destinations. In other words, where is the sensitive data that we've detected in this application flowing to? And in this case, it's going to various data sinks. And so what you can see is these triggers effectively cause these data flows to happen. And that's why we're also seeing, calls per minute traffic on data going out to the log, data going out to the web, and other locations as well. So right away, I think I'm going to dig into a critical use case that stands out to me, which is payment data going to the log. So the reason this is highlighted red is, fairly obviously payment data is likely not supposed to go to the log file, especially unencrypted. And so if I click on this, it will filter the whole experience. And now we're looking at individual Java variables. So these Java variables were all classified as payment data. So I'll just take a moment to explain or maybe reiterate how this works. Because the ShiftLeft solution is ultimately looking at the data flows of the application in order to uncover security problems like vulnerabilities, we can leverage that same approach to identify what is sensitive data implied by the code and what is the sensitive data that is happening, that is potentially leaking at, or likely leaking at runtime. And so what we look at is the names of the variables. In this case, it's account number, initial balance, and so on. The names of the variables in a natural language processing way, and automatically classify that as payment data or PII or authentication data. So in this case, I'm going to click on account number, and what we can see here is the sort of lowest depth you can get to, where we're now looking at the variable called account number up here. And in this screen down here, we're looking at what we call the data flow trace, where a certain trigger has initiated the data flow, and we're looking at lines of code of various methods that either transform or just touch account number as it reaches the end of this flow. And so you can see at the very bottom where this flow concludes with a logging statement. And this logging statement is, of course, what's taking a parameter, and that parameter is receiving what was named an account number previously, and then saving it out to the log inappropriately. And so this is a pretty unprecedented workflow I just sort of demonstrated here, where we started out at a very high level looking at the operational context of the application with sort of an overlay of security issues that you can go look at. And then finally, a few clicks later, I can get down to the level of specificity of a line of code. And I can just open a Jira ticket right now, potentially, and get a developer involved to resolve this problem. So if I go back to the main application view, I'll just introduce you to a couple of other aspects of the experience here. So I've really gone from high level into depth on a particular security issue, in this case a data leak. What I'll show you now is there's also an alerting system, and maybe this is a great way to just broach who are the different users of this application. So we believe that there are three primary actors. We know that not every company has every role, but in the case of at least the design team at ShiftLeft, we talk about engineers, we talk about DevOps or operations or site reliability engineers, like we kind of group those together. And finally, security engineers and security leadership. And so while you can get code level visibility, which we think is obviously more catered to engineering, in terms of the security professionals, at least, there are these high level experiences like the alerts dashboard and the violations list, which can give a very high level bird's eye view of the security issues. And we're discussing how this can also be integrated with SIMs or network operations centers. And so here are the violations. These are effectively the same ones that you could see overlaid on more of the DevOps friendly dashboard. But these violations also include, as I point out, these injection vulnerabilities, which I didn't really get a chance to show you yet. So here's an example where we're looking at the violation detail of what we call attacker control data to SPEL. What this effectively means is this particular application can receive an input from the internet that would be able to execute an arbitrary command in the code. So obviously this is a very severe issue that I would resolve right away if it were my application. However, in this case, we don't have any example of this happening at runtime yet because I haven't tried to hack this app. We believe this is a powerful solution. It could be a collaborative touch point for these three roles that I've described. And so yeah, this is what we think is very exciting. So that concludes the demo from me. Any final words, Manish? Okay, well, thank you everyone for joining. It was a pleasure to talk to you and show you what we're all about. Have a good rest of your day.